Today we will solve uh, Jest-2018 EMT questions. So this is the first question. Two dielectric spheres of radius r are separated by a distance a. Two dielectric spheres, suppose this is two dielectric sphere, okay, of radius r separated by distance a such that a is much greater than r. One of the sphere 1, so this is sphere 1 and this is sphere 2. One of the sphere has a charge q and other is neutral. If the linear dimension of the systems are scaled up by a factor 2, by what factor should the charge on the sphere 1 be changed so that the force between the two spheres remain unchanged? Okay, let us draw according to the question. Sphere 1 of radius r. 2 also have radius 1 and sphere 1 bearing charge q and 2 is neutral. Due to this charge and both are dielectric, so due to this charge q, it produces electric field on its surface. That electric field is equal to q by r square. Due to this electric field, let us suppose that electric field is like this, flux are coming this like this. So due to this neutral sphere get polarized. Due to polarization, uh, on its surface a charge q will induce, that is q. Okay, and according to the question, the distance between the two sphere is a. As a is much greater than r, both the two sphere can be we can think that both are like point charges. So force between those spheres will be k q square by a square. Okay, this is our one equation. Then let's see what will be the question in the next. If the linear dimension of the system are scaled up by factor 2, that means, okay, sphere 1, sphere 2, linear dimension, that is 2a. So what will be the charge on this sphere, sphere 1, so that force will be remain same. So this is q dash, and due to the induction polarization, that is q as you know from this. So force between the two sphere will be now F dash is equal to k q dash q divided by 2a square. Okay. That is k q dash q by 4a square. Equation 2. Equate equation 1 and 2. F dash is equal to f. According to the question, that implies q will be q dash by 4. So q dash will be 4q. So that our force remains same after the linear dimension up to factor by 2. Okay, this question done, that is option C. Let's go to the next slide. Okay, next question is, two parallel rails of a railroad track are insulated from each other, and from the ground the distance between the rail is 1 meter. Okay, a voltmeter is electrically connected between the rails. Assume the vertical component of the earth magnetic field to the 0.2 volts. Okay, what is the voltage developed between the rails when a train travels at a speed 180 km per hour, okay, along the track? So according to the question, let us consider two parallel rail tracks. Okay, two parallel rail tracks. This is train is traveling with speed, some speed. and magnetic field is vertically upward. So this is magnetic field vertically upward, and in between that is train is moving, and here voltmeter, and this will be the resistance produced due to the moving train. This is the condition of motional EMF. So that according to the motional EMF, as we know, flux is equal to no flux EMF induced will be VL, and so B is given, B is given, and L is given. So you can find the answer motional EMF. Let's go to the next question. An electromagnetic wave of wavelength lambda is incident normally on a dielectric slab of thickness T. Okay. If K is the dielectric constant of the slab, the change in phase of the emergent wave compared with the case of propagation in the absence of dielectric slab. Okay. In electromagnetic wave of wavelength lambda incident normally on a dielectric slab. Okay. The thickness is D. Okay, thickness D. So what will be the emergent wave? Emergent wave. Okay, as in the absence of dielectric slab. Okay, as you know, phase difference is equal to 2 pi by lambda of path difference, and in case dielectric slab, path difference is equal to mu minus 1 whole into T. Remember it. In, in any medium, mu is the refractive index, T is the thickness. So here delta x is equal to as you know, mu is equal to K is equal to root K. So delta x will be root K minus 1. Here thickness is D. So put it in here. Phase difference will be 2 pi by lambda into root K minus 1 whole into D. Is the answer. Here is our next question. Two conductors are embedded in a material whose conductivity is 10 power minus 4 and dielectric constant 80 epsilon. The resistance between the two conductors is 10 power 6 ohm. What is the capacitance between the two conductors? Okay, two conductors whose conductivity, that is sigma, is equal to 10 power minus 4 and epsilon given 80 epsilon naught and resistance 10 power 6. So what is the capacitance between the two conductors? As you know, capacitance is equal to epsilon r epsilon naught a by t, and also we know r equal to rho l by a. Here l is t. So a by t is equal to rho by r, and as we know, rho is equal to 1 by sigma to r. Resistivity is reciprocal of conductivity. put this value here. Epsilon r epsilon naught 1 by sigma r. Epsilon r is 80, epsilon naught sorry, this is not epsilon naught. This is epsilon a by d. Here epsilon given. Okay, this is epsilon. This is epsilon r and epsilon naught. Divided by sigma is 10 power minus 4 into r is the 10 power 6. So put the epsilon naught value 80 into 8.85 into 10 power minus 12 divided by 10 power 2. So solve this, we'll get the answer. Let's go to the next question. Thank you. All the EMT part is finished. Please do subscribe and share my channel.